We're going to pick up with the last three proofs from our proof booklet. So the next one says, given that angle ABC and CBD form a linear pair, prove that angle ABC and CBD are supplementary. So we're going to start always with what we were given, which is that angle ABC and CBD are, or form rather, a linear pair. And the reason is that it is what's given to us. My goal in the end is to prove they're supplementary. So when I think about that, I think about the fact that they add to 180 degrees is probably going to be my step before that, because that's the definition of supplementary. And then I think, okay, it's telling me it's a linear pair, which means we maybe want to talk about it being a straight angle, because a straight angle means that it is going to be 180 degrees, which can connect my goal of it being supplementary. So these are just the things I'm kind of thinking through before I start writing stuff down. The other thing that's going to be helpful is if I sketch a picture. So I have A, B, C, and C, B, D. And since it says that's going to form a line, I am going to draw it just like that. Notice I don't know if really ABC is acute or obtuse or right angle. We're just sketching a picture, and it will work no matter what angle that is. So this would mean that angle ABD is straight. And the reason I can say it's a straight angle is that that's the definition of a linear pair. And the definition of a straight angle is that the measure of that angle is 180 degrees. Definition of a straight angle. And the next one, we haven't used this reason yet, but what we're wanting eventually is to say that if I add ABC and add CBD, that I'm going to get 180 degrees, because then I can say they're supplementary. But before that, we need to use the fact that I can even add those angles. So I'm going to say that angle ABC, or rather the measure, let's see, the measure of angle ABC plus the measure of angle CBD is equal to the measure of angle ABD. So just that the two parts make the whole. And that's called the angle addition postulate. We've done that a lot in actual problems. We're just using it now in my proof. Now I can substitute that in. So now I can say measure of angle ABC plus measure of angle CBD is 180 by substitution. And I almost had enough room. My last line, I'm going to squeeze over here, is that angle AB, I'm having trouble writing today, sorry y'all. Angle A, B, C, and angle C, B, D are supplementary and that's by definition of supplementary. So that should go in the other column. So you want to kind of think through where you're starting and where you want to go before you really start writing down your plan and your actual proof. Just kind of think through what your steps might be, and that can help you get started. The next proof gives you a diagram, which is nice. And what this is going to prove for us is the vertical angle theorem, which once again we've been using, but now we're going to prove it's true. And also, while I'm writing this down, if you look at below that proof in your booklet, it gave you the linear pair postulate, which we're actually going to find super useful in this proof right here. It's going to save us a lot of time because we can say, since they are a linear pair, that they are supplementary. So if angle 5 and 6 are a linear pair, and angle 6 and angle 7 are a linear pair, we want to prove that angle 5 is congruent to angle 7. So we are going to do our two-column proof. You always start off with your givens. So I have my statements and my reasons. You could kind of look at how much room I've blocked off for you. This is going to be a really short proof because I just proved the linear pair postulate. So my given is that angle 5, angle 6 are a linear pair. I'm abbreviating a little bit for time. And angle 6, angle 7 are a linear pair. And I'm going to fit all of that into that first spot on your paper. That is given. The definition, or coming from our linear pair postulate we just did, is that the measure well, actually, let's start with that angle 5, angle 6 are supplementary. And angle 6, angle 7 are supplementary. And then that's going to be the linear pair postulate. If you remember way back from Tuesday when we first started looking at proof, one of the ones we did was the congruent supplement theorem. And if you notice in this line, they both have angle 6. And what we concluded from the congruent supplement theorem is that if two of the angles are supplementary to the same angle, then they are congruent. So from that theorem, I can conclude that angle 5 is congruent to angle 7, and that was the congruent supplements theorem. And I'm actually done with my proof at that point. So this is why proving these little things are really helpful, because after I do them, I can use them. And if you flip back one page and look at the congruent supplements theorem, it was really kind of a longer proof. So now I can do this and skip a whole bunch of steps. And once again, that came from, I noticed I have the same angle and these two are both supplementary. So then that means that the other angles mentioned are going to be congruent to each other. They have to be the same thing. So I'm actually done with my proof, and this just proved that these vertical angles are always congruent. And I just realized somehow I copied down that as a 3 instead of a 7. Oopsie. So that just proved our vertical angles theorem. We've already used to solve some algebra, but now we have the proof of the theorem in general. Okay, and now we have one more proof. This time I didn't really give you the structure, trying to build it up so that you can start doing it without being told how many steps. And we've discussed in class that you could have a different number of steps depending on how you approach and lay out your proof. So those ones that I've been giving you are really just a suggestion. So angle N and angle M are congruent and supplementary. We're going to prove that angle M and angle N are right angles. So I'm thinking about the fact that they're congruent. That means that their measures are equal, so I'm thinking I'm going to use that. And then it also means that their measures add to 180 degrees. And then I kind of think if I'm trying to prove they're right angles, I want to prove that their measures both equal 90 degrees. So that gives me kind of my overall idea of what I'm going to do for my proof. You could jot those down in the corner of your page as you're thinking through. It's always good to just kind of pre-plan and think a little bit about where you're going to go. All right, so what's the first thing we always need to write in our proof? That's going to be our given. So we're given that angle N and angle M are congruent, and they are supplementary. Angle N, angle M are supplementary. So I have two pieces of information. I am personally going to start with the first thing that we were given and see what I can get from that. So I'm going to start with this. If we just started with that, those are congruent, then I can say that the measure of angle N is equal to the measure of angle M, and that's by definition of congruent angles. After that, I can't really go anywhere right now, so I'm going to move down to the second given, that they are supplementary. So I can say that measure of angle N plus the measure of angle M equals 180 degrees, and that's by definition of supplementary. Once again, I can't really go anywhere from there, so what I consider is there a way to combine the two things I know right here? Well, they both have angle N and angle N. So I'm going to substitute in angle M. You could do the same idea and get rid of angle M and use N. I really hate how these letters sound exactly the same. But what I'm going to do is replace angle N, personally. Does it matter? Not really, because they're equal. So I'm just going to replace that for my next line. And all I did was substitute, so my reason is substitution. And it's really substitution, property of equality, but we don't have time to write all that down. Now, it looks like you have a hot mess on the left, but notice this is really, I have one measure of angle M plus one measure of angle M, which gives me two measures of angle M equals 180. Do you have an idea? So that's just simplifying or combine like terms. I'm going to say combine like terms. Okay. And now what I can do is divide both sides by 2, and I get that angle, the measure of angle M is 90 degrees. And that was by the division property of equality. Which if I've been working on this proof for a while, so sometimes you lose track of where we were even trying to go. I was trying to prove that angle M and angle N are right angles. Well, what does a right angle mean? It means it's 90 degrees. So I'm going to hop to first, I want to make the same statement about angle N. So angle N is equal to 90 degrees by definition of equality, that both of those are equal to 90 degrees. And my last line, of course, just need room for my last line because that's how it works, is that angle M and angle N are right angles. And that's just by definition of what a right angle is. So that's my reason is definition of right angles. I think I'm going to run out of room. Yay, I did it. Definition of a right angle. And we're done. That was a long proof, so take a deep breath. All right, we're going to keep on working on proof for literally the rest of the semester. So if you got stuck and probably didn't understand some of that because it's your first time really with proof, feel free to, rewind it, look at the steps again, and try to think that through.